let me talk about how I would solve this problem. So what I have here is I have two primary cross sections. I have the curved kind of main profile of the part, and then I have the top profile with the various holes and slots on it. I want to generate that primary geometry first, and then cut out the kind of complex top geometry. And I'm going to do this the way that kind of I think is the easiest. So in SolidWorks, I'm going to start with just a single curve, and I'm going to do a thin extrude. So I'm going to do part. This part is in inch pound second. So I'll make sure that I'm in the inch pound second unit system. So as soon as that part's loaded up, I'll change my units to inch pound second. I'm also using a stainless steel. So I'm using 316 stainless steel. So I'm going to go ahead and change that right off the bat, just so I know that I have the right material. I don't worry about that being an error later on. I'm going to go to the right plane on this case because I'm actually going to sketching mostly on the top on the right to better match what I have inside the drawing. In the right plane, I'm going to use a center point arc. And I'm just going to draw the arc that I want this to be. I'm not getting the direction that I want there, so I'm just going to go around. And I want this to have a radius of 1 inch. And I do want it to be centered, not because it matters per se, but it's going to help me to put in the rest of the things later on. So I'm going to exit the Smart Dimension tool. I'm going to put the center vertical below the side. And I'm going to put these two side lines horizontal, or the side points horizontal with my origin as well, just to kind of keep it in position. And then I want this width to be something that's bigger than the 0.5, because when I thin extrude, I'm actually going to be thin extruding it down, and I want to make sure it's bigger than what I need. So I'll use 0.7. And you notice this is a fairly thin arc. From that thin arc, I'll move these down so you can see it a little bit better. I'm going to use a extruded boss base. Your default extruded boss base should probably always be a midplane. And I want to use the length here. I'm actually going to exit this because I haven't put in any variables yet. So I'll go to my equations. I'll say L is equal to, I forget what it is by the default here. I'll go to the quiz, close that. 7 is the first one. So we'll say L is equal to 7. I'm going to say inches. I like to put the units in for those to start off with, and S is equal to 3, because if it converts to something else, I forgot to change my unit system. So just a quick check for me, doesn't use up that much extra time. And then inside this thin extrude, I want this distance to be equal to my L. I could make it bigger than L, but in this case, I don't need it to be because it's going to have flat sides anyways. Once I've got that primary bar, my next goal is to make the cross section for the bar itself. Now, the bar itself and the slot are not changing as a function of the number of holes. So I want to do the holes separate, but for the bar and the slot, I can do those in the same feature because both of them are just a function of the basic geometry and the length. So I'm going to use the slot tool, the straight slot. I'm going to go all the way across, drag it out. I'm going to do it again. I'm going to go about, a certain distance of ways across and drag it out. Then I'm going to exit the slot tool. I just did those two to start off with because I wanted them to both be done without exiting and entering tools. So if I know I'm going to need like 5 circles, draw the 5 circles and get them on the page so you can exit the circle tool and then start putting in dimensions. And that's a good general rule. Just make sure that you have the dimensions on the page, and then you can go through and add all the relations you want. So I'm putting the centers of my slots on the origin. I'm going to make the length of the middle one 1 inch. And if I go back to my drawing, you can see that the length of the middle slot is just 1 inch. It's not varying. It also has a radius of 0.1. When I first made this, I actually made it like 3/16, and that rounds to like 0.0837 or 1837 or something. But I wanted to make it easier for you all, so I just made it 0.1. And then I want the radius of my outer one to be, I think, 0.25. Go back. The radius of the outer one to be 0.25. And that also makes the total thickness 0.5, so I don't need to specify that. And then I do want this length to be the same, so I'm going to make these tangent on the end. And since I put the center point aligned with the center, I don't actually need to tangent both sides. It just works out that it's the right length. So that gives me the length that I want. I'm gonna go to my features. I'm gonna do an extruded cut. I'm going kind of halfway through this, so I need to do in both directions. And I don't want to cut out the inside of this. I want to save all the inside portions. So I'm going to flip the side to cut, and that's going to get rid of everything outside the sketch, keep everything inside the sketch. Where a normal cut will keep all the outside portions and throw away the inside portions. So that gives me the majority of my geometry pretty quickly. Now I need to add my holes and my fillets. So I'm going to go back to my top plane. I'm going to sketch, and you can hole wizard for this too. I'm going to draw one hole coincident with this endpoint, and it's going to have a diameter of 0.2. So I'm going to give it a diameter of 0.2. I'm going to make it a through all cut. So I'm going to do through all in both directions. And then I'm going to pattern this hole based off of my equations. So here, that's the direction along the line. The distance is going to be equal to global variables L divided by 2 minus 1.25. Oh, not 1.25. That whole thing in parentheses divided by S minus 1. I could. Yeah, I could have that distance in my global variables and then just use that as opposed to typing the equation here. I'm not sure what the advantage of that necessarily would be. And then this is going to be equal to S. Yeah, go ahead.
Can you make, like, does it process the global variable? So if I had S as a global variable, could I put S next?
Yeah, top to bottom. And we actually did that last class because we had our gear ratio and our spacing, and we use those to calculate the die in, the die out. So yes, you can have equations in those global variables sheets, right? And we can link them out to a file, and we can make a bunch of things all dependent upon those parameters, right? I do need to make sure I have the S in quotes here. I typed in as S, it doesn't recognize that as a global variable. So you have to tell it like, hey, this is the variable S by putting it inside those quotes. And we have that again pretty easily. I'm going to pattern that about the right plane. Again, that's why I'm using that mid-plane extrude, because it gives me these planes I can use that transect the center of my part. And then I'm going to add a fillet to the top and the bottom. And usually it's easier to interpret, like, what do I mean by top and bottom as you're working on the part? This is the top of the part. This is the bottom of the part. So the top needs a fillet of 0.05. And then the bottom needs a fillet of 0.2, or so 0.02. And that should be my part. Not too bad, right? Again, the hard part there is knowing when to use what features. As a general rule, I would strongly recommend that whenever you're doing a mirror or a pattern, if you can, do it as a feature, not as a sketch. The sketches, when you do a mirror or pattern, what it tries to do is it tries to create a set of entities and relations that makes the pattern or the mirror. It doesn't save that operation. It doesn't know that this feature was made using a mirror or whatever. It just says, I have a line that is the same length as that other line, and they're symmetric about the center line, which is not as resilient to change as the actual mirror and pattern features that say, hey, you want X number of things in Y direction with this spacing, right? Or you want it mirrored about this plane. So if you can, use the three-dimensional geometry, fillets, rounds, campers, mirrors, patterns, and not the sketch entity versions of that. I'm going to evaluate this. So I'll go to, evaluate mass properties. And I don't have the appropriate number of units here. So I'm going to go to options. I'll use custom units, change it to 3 or 4 decimal places, and pick your poison. And then I'll compare that to my answers. I have 0.85, 0.852. That's the right answer there. Then it says if I make my L 5.9 and my S 4, what do I get? I'm going to close this, go into tools, equations. You do need to close that mass properties tool, it won't update until you close it and open it again. So just watch out for that. And what I said 5.9 and 4, 5.9 and 4. You can copy and paste if you want, just so you don't type in things wrong, which I would do if it wasn't just a 2-digit number. Okay. And you can say automatically updated. And I can do my mass properties again, 0.0673. So 0.0673. Also do a quick logic check on here. I went from 0.85. I made it shorter and added more holes. My mask went down. Makes sense. It's always good to think about that just to make sure you're not making something blind. You can submit that. And you can say, I got that one right. I got that one right. Yata. I put in more digits than I was asked for, but it doesn't care. Maybe it should. I don't know. And the nice thing about things like this is that now that I have this part, I can really, make kind of whatever I want, and it should be pretty resilient to change. So if I want a 10-inch long bone plate that has 8 screws on both sides, there's a 10-inch long bone plate with 8 screws. And if I wanted to, I can make that center slot distance variable, and I could make more kind of parameters for the spacing. So if you wanted spacings that were, some kind of zigzag pattern or something like that, you could do that too. You can kind of imagine, hopefully, how you could add a lot of complexity into this and then generate a lot of different models based off of, a couple of different parameters. So any questions on that? Yeah, I started with a thin extrude. I would always recommend that start with the simplest geometry that will work for the part that you're making. Any step forward that you can do, that's going to give you, try and get 80% of the geometry, and then 90%, and then 100%. Don't try to go straight from 0 to 100%, because you're not generally going to be as resilient as if you had kind of stepped it out piece by piece. And think about how something like this is going to be made. If I'm going to make a bone plate like this, I'm going to start off with a bent piece of sheet metal, and I'm going to mill around the edges and drill the holes, right? And that's kind of what I have here. I've got a bent piece of sheet metal. I drilled the general profile. I drill the holes, right? And drill the holes on the other side. And then I'm going to add some rounds to them. Right? That order that I have in my model tree does mimic the order of operations that you would perform as part of manufacturing this part, which is beneficial to me in terms of a design intent standpoint, as well as a transfer engineering, being able to transfer this part from design to manufacturing, right? Oh, good. All right, we got a few minutes left. We're going to start in on the lesson. We'll get as far as we can today, and then we're going to finish it off on Wednesday. And hopefully you all are starting to think about ideas that you have for your project, your mini project one, the Rube Goldberg device, as well as your design projects. Again, if you want to bounce those off of me, I encourage you to do that. So let's close this out. I'm not going to save it. And I'm going to do a new part. And this part, we're going to follow along with the worksheet on our week 2 lesson page for the table box. And our goal, oh, this is not the updated one. There's not that much different from the updated one and the new one. I took the links out because the links are talking about molding. I wanted to have them in a later lecture. So just ignore those links. I mean, you can watch them, but we're going to watch them again later. It's a box. Huzzah. So in this part, what I want to do is I want to make a box that has tapered walls, make it easier for me to injection mold that box. And I want to have mounting points inside the box that maintain themselves based off of spacings that I specify. And again, making a box that is resilient to changes in design parameters, and then quickly changing those parameters. And this time, instead of using global variables, we're going to use what's called a design table. So design table allows me to basically make an Excel sheet that has a bunch of different part values in it. And then SolidWorks will take those part values and generate configurations matching the different things I put in. So equations are really like, I have one set of parameters I'm trying to optimize. Design tables are, I have a bunch of different options for part sizes that I want to be able to toggle between, okay? So let's start off with making this box. This is a center point rectangle that has a width of 100 millimeters and a height of 60 millimeters. And we're gonna extrude it to a depth of 40 millimeters. So it's 10 by 60 by 40. And we're actually gonna make some tapered walls here as well. So I'm gonna go to the top plane. I'm gonna sketch. I'm gonna use a center point rectangle. I am in MMGS, by the way. You guys wanna check that or not? And I want the width of this, so using the smart dimension, to be 100. I can just use the length. I use the sides a lot as a default, just as like a heritage operation in case you want to round the sides later. But we want 100 by 60. And then I want to extrude this. So I'm going to go into features, extruded boss base, and I want to add a taper to this that goes outwards. So if you look at the draft options and then the draft outward box, this is going to be a height of 40. And make sure that option is checked in this outward draft. And I think I want a draft of 2 degrees. 2 degrees is a pretty common draft angle to be used in injection molding because it's large enough that the mold will easily release, or the part will easily release from the mold. But it's small enough that it's not really very obvious to someone just holding a part. So this will make this thing stackable, moldable, and it's straight enough on the sides that people don't care, right? That make sense? Anyone having issues getting the box in? This is the follow along part, so hopefully you guys are all okay. I'm going to accept that, and I've got a solid box. I want to thin this out, and I'm going to thin it out after I add some rounds to it because I don't want it to have hard edges. I want it to have soft edges. So I'm going to go through and I'm going to add a 5 millimeter radius to all the outside edges and all of the bottom edges. So in the bottom being the top plane where I started the extrude. So I'm going to go into my fillet. I'm going to type in a size of 5. I always like to put in the size of the radius first, just so it doesn't have any issues. And I prefer to have the preview on. So I'm going to do the bottom of the box, which is the smaller of the 2 faces, if you want to look at it, like from the top of the bottom, as well as the 4 sides. I'm not going to do the top. The top's going to stay flat. And the reason I'm doing it this way is because I want constant wall thicknesses. And if I did a thin extrude, it'd be hard for me to get the rounds. And if I were trying shell before I did the rounds wouldn't have clean edges. So I really want to do the shell kind of after I've got the primary exterior features of the box done. This is also nice because it's got a nice flat top still. So it doesn't have any weird angled edges or something. And I want a wall thickness of 2 millimeters. Does anyone have any error getting that good? Are we still all on track? Like your part's not visualizing? I've seen this happen before in SolidWorks, but the parts just aren't visualizing. Save the part. Okay. By saving it, close the part. Normally close all of SolidWorks, but just close the part and open the part again. Anyone else having issues with not getting what got up here? All right. What I'm gonna do is I'm gonna shell this out. So I'm gonna go to my shell tool. And I want a thickness of 2 millimeters. I do want to show the preview. And you can see here that right now, without selecting any faces, I have a totally empty box with no opening. Not what I want. I want to have an opening. But what the shell tool does is it empties out the inner portions of the geometry, then has openings wherever you select faces. So you can see I've got 2 openings, one on the side. I've got an opening on the top, an opening on the bottom. A little hard to see on that one. But you click all the faces that you want the openings to exist on. So if I click just the top face, I have an opening on the top and I've got a nice box. You know, you can get complicated with this. If I click on the bottom face, And I've got like a weirder box. If I click on the top face and the bottom face, I've got a tube, right? Just kind of showing you guys how kind of convenient and useful the shell tool can be. If you want a box that has a certain thickness of sidewall and a certain thickness of bottom wall, you can have a multi-thickness setting. So I can make the bottom thicker than the top. Well, not that much thicker than the top. Now, this one's gonna be a little bit weird because of the rounds, because it's gonna be 2 millimeters thick on these rounds and 3 millimeters thick on the bottom. So if you wanted to do that, you probably should include the rounded portion of the bottom. You're gonna have a little bit of a lip there. And there's other ways you can do that that might be better. We don't really care about any of that. So I'm gonna just delete this face. So I have a single thickness. My phone is vibrating. Scam likely. Why do I always get scam likely calls during this class? Someone's trying to distract me. Maybe it was Reed. So there's my box. We're almost out of time. I want to talk a little bit about adding some features to this, and then we'll call it a day and we'll pick it up in class next time. And so the next thing I'm going to add to this is just a peg that I'll use as a mounting pole for this box. And one of the things that I want to do with this is that I want the height of these pegs to be a certain distance from the bottom of the box. And if that's the case, really what I want to do is I want to sketch on the top plane and then extrude up, but I can also sketch from whatever plane I want and then pick a new plane to start from and then have it come out. So in this one here, what it's showing is I can start from the face of the part and I can extrude it up to that 8 millimeters. So in here, I'm going to go to the top plane. I'm going to sketch. I'm going to draw a circle. I'm going to specify that that circle has a diameter of 8 millimeters. And I'm going to put the distance from the edge of the part to the center of the circle. I'm going to make that, I think it's 15, so 15 millimeters. The edge of the top of the part and the center of the circle is going to be 15 millimeters. So it looks just like that. And then I'm going to have this come up from the bottom of the inside of the box. So right now, you can see that part is down there. But what I'm going to do is I'm going to do an extruded boss base. And then rather than starting from the sketch plane, I'm going to start from a surface. Click on the inside of the box. So now the peg is starting on the inside of the box. You can kind of see that there. And I want to make it a height of 8 millimeters. I also, on this peg, want to include my draft. So inside my features, I'm going to use the same 2-degree draft angle. This time I'm going to draft inwards because I want, again, you got to think about how it's going to release from the mold, right? So if the mold's coming up off this part, this needs to draft inward so it looks like kind of a cone. And you should see that if I look down from the top and I have the appropriate draft angle, none of the edges are hidden underneath another face, right? They're all kind of on the top. We go to 420, right? That's our end time. Right. So we'll stop there for now and we'll pick up with this in class on Wednesday. On Wednesday, we'll finish adding these features to the box. I'll show you guys some alternate ways you can use some default tools for adding mounting points to plastic components. Well, not just plastic components, but mostly plastic components. And then we'll talk about how to drive a lid based off the box as well as the design table kind of aspect of this. So hopefully you're looking forward to that on Wednesday. I'm going to stop recording.